formula says P represents a certain bee population at time t, and this is our equation that we're using, the formula. We're going to answer all of these questions. So part A says, determine the number of bees at t equals 0. So what are you going to do to answer part A? Put in 0 for t. Go ahead and do that. You probably shouldn't need a calculator, but if you do, go ahead. But you should know that e to the power of 0 will be 1. And 350 times 1 is 350. But if you're not sure, go ahead and substitute in 0. So for part A, you have, yep, so you're going to use that exact formula. The formula is given to you. So that stands for a 4% increase. So this bee population has an increase of 4% each day. So at t equals 0, substitute that in, and you should get that there will be, at the beginning, 350 bees. The growth rate of the population is in the exponent, okay? So the growth rate is R. So this here, oops, that's kind of thick. This stands for your rate. Because remember, if you go back to the formula we talked about yesterday, it was e to the power of RT. R was the rate, T was time. So same situation here. Your growth rate is 0. I'm going to write at the bottom. 0.04 or 4%. Because if you multiply that by 100, that becomes 4%. For part C, how are you going to figure that out? What is the population after 9 days? What are you going to substitute into the equation for T? 9. So we got to pay attention though, because this one tells you that T is measured in what? In days. So in the equation, this one, it says that now T represents days, not years. So make sure you highlight, circle that. So for this one, we're just substituting in a 9. So for part C, the population is going to be 350, and then it's to the power of 0.04 times 9. Go ahead, type that in. And we're going to round that to the whole number. I made sure that every single question said where to round. Some of them is the hundredths place, some the tenths place, some is to a whole number. But I made sure that every single question says clearly what place to round to. So that shouldn't be a problem when you take your test next week. So I'm going to type this in real quick because I don't have my notes next to me with my answer key. Second function ln, 0.04 times 9. So I get approximately 502 bees. Approximately. Oh yeah, let me put that there. Thank you. So to put the E, you hit the green key and ln, because ln and E are inverses, so they share a key. All right, part D says, when will the population reach 800? So the population is going to reach 800. That means P is going to equal 800. Now we have to solve it for T. So 800 equals 350 E, and then it's 0.04 T. How are you going to solve this on the test? What is the first step you're going to do to solve it for T? Can't put in the ln yet. We got to get rid of the 350. And how do we get rid of the 350? Divide it. E has to be isolated before you put in the ln. So because I want to keep my answer exact, I'm not going to convert that to a decimal. I'm going to reduce it, but I'm not going to change that to a decimal just yet because I want my answer to be exact. So that fraction is going to reduce down to 16/7. You don't want to round until you get to the end because that's going to affect the accuracy of your answer. Now, you can also just leave it as 800/350. You don't even have to reduce it. Now, we're ready to put in our natural log. Which is going to cancel that out. Which gives you the natural log of 16/7. That equals 0.04 times the days. And then your last step is to divide both sides by 0.04. So pick this up in your calculator. Or not pick this up, type that in your calculator just like that. So you're going to hit the fraction key. You're going to have the natural log. There should be a fraction in the top. If your calculator is not coming up with the fraction when you hit the fraction bar, you can bring up your calculator. I can fix it for you. It's just a setting that needs to be changed in the mode. But natural log of 16/7 yeah. So we're going to round. So the population, whenever we're talking about, we're talking about time. So for time, I think on the test it said round to the 10th place, but for here we'll just round to the whole number. So I got 21 days, 20.6, which rounds to 21. So in 21 days, so when t equals 21 days, that's when we'll have a population. I'm just writing it as a sentence. Of course, you don't have to, but I want you to understand what we just figured out, that at 21 days, that's when we'll have 800 bees. All right, and then our last part, part E, says when will the bee population triple? So if I want to know when it's tripling, keep in mind that we already said that in part A, it says we started with 350. So to figure out the population when it triples, we're going to take 350 times 3. And 350 times 3 is what, 1,050? Yeah. So we'll have 1,050. So this is part E. 1,050 equals 350 E. Hold on, I need more space. To the power of 0.04 t. What's our first step going to be? Divide both sides by 350. And that's when you'll have your 3 equals E to the power of 0.04 t. Enter in the natural log. And that gives you the natural log of 3 equals 0.04 t. And then we're going to divide both sides by that rate. And we'll round it to the whole number again. And you should get approximately 27 days. So at t equals 27 days, that's when the population will triple. Any questions about that last word problem there? So what I will say is, first of all, I shortened homework 22 and it should be updated. This, I literally formatted it to look just like the last homework question. So I just gave you a different formula, but the same 5 questions. So use these notes to help you with homework 22. All right, let's go.